Imagine checking the time on Mars and realizing that the planet is literally running ahead of you. According to new calculations from physicists at the National Institute of Standards and Technology, time actually runs faster on Mars, and we now know exactly how much faster. Every single Martian day, clocks there tick 477 microseconds ahead of clocks on Earth. That's less than a blink, but it's a huge deal for scientists planning future colonies, communication networks, and landing missions. And this tiny difference comes straight from Einstein's general theory of relativity. Einstein predicted that gravity controls the flow of time. The weaker the gravity, the faster time moves. Mars has only about 1/5 of Earth's surface gravity, so naturally its clocks speed up. But gravity isn't the only player. Mars has a more stretched out orbit, meaning its distance from the Sun changes a lot more than Earth's does. Those orbital shifts cause time to speed up and slow down throughout the Martian year. Using data from NASA's Mars Reconnaissance Orbiter and extremely precise models of planetary motion, the researchers found that this 477 microsecond gain isn't constant. It can vary by about 226 microseconds depending on where Mars is in its orbit. Over a full Martian year, 687 Earth days, this adds up to almost a third of a second. That doesn't sound like much, but for spacecraft navigation, it's enormous. To put it in perspective, GPS on Earth requires timing accuracy down to billionths of a second. If humans ever want a Martian version of GPS or a fast communication network between the two planets, these small offsets must be corrected. Even robotic missions could end up missing their target by miles if their clocks aren't synced. Physicist Neil Ashby explains it simply. Just like Earth uses UTC, the universal clock, future astronauts will need a Martian equivalent, a new interplanetary time zone based on clocks ticking on the red planet itself. This is the first step toward a true solar system internet, where Earth, the Moon, and Mars all share a unified timing system. And there's another side to all this: testing Einstein. Mars offers a natural laboratory for observing relativity in action. The team even included tiny effects from the Sun's gravitational pull on Earth's orbit, allowing their model to reach precision levels of about 100 nanoseconds per day. That's the time it takes light to travel just 3 centimeters. What this research really shows is that if we want humans living and working on Mars, we need to rethink time itself. Our clocks, our communication systems, even our navigation methods. Everything must adjust to a universe where time bends differently from world to world. As NASA pushes forward with its Moon-to-Mars plans, the idea of a universal time system for the inner solar system is no longer science fiction. It's becoming a requirement for the future of space travel. One day, we won't just ask, what time is it on Mars? We'll actually be living by it.